Hello friends, in this video we will see solar cell and their application, that is the presentations, and we see some topics, that is introduction of solar cell, construction, working of solar cell, solar parameter, applications, advantages and disadvantages, and conclusion. First of all, we will see introduction. A solar cell is a solid state electrical device that converts light energy into electrical energy by the photovoltaic effect. And if we connect solar cell together, then we can form a solar panel. And in 1905, Albert Einstein understood that the photoelectric effect could be explained by assuming that light consists of well-defined energy quanta called photon. The energy of photon, that is E equals to h nu, where nu is the frequency of light. In 1921, Albert Einstein received the Nobel Prize by explanation the photoelectric effect. Let's move to the next slide, that is construction of solar cell. Photons in sunlight hit the solar panel and are absorbed by semiconducting materials such as doped silicon. We use silicon as a semiconductor material in the solar panel. Consists of p-n junction diode in which n region has small thickness of about 0.3 micrometer. The p region has large thickness, that is 300 micrometer. The thickness of the p region is greater than the n region. The n region is made up thin, so light falling on the solar cell is not absorbed significantly before reaching the junction. And on the top of the n-type silicon material we deposit fingers, because if light incident on solar panel, then it generates electrons, and electrons can easily move through the metallic finger, so we use metallic finger over the n-type. We don't use germanium in solar cell because germanium has a band gap of 0.65 electron volt, and the structure of silicon germanium is destroyed at high temperature. So we use silicon in the solar cell because the band gap of the silicon is 1.1 electron volt, and silicon crystal are not easily destroyed. So this is the viva question, why we use silicon in solar cell as at the place of the germanium. Let's move to the next slide, that is working of solar cell. The working of solar cell are based on three processes. First is generation of charge carrier due to the absorption of photons in the material that form a junction. If we know that there is two energy level, that is uh, initial and final, and photons can only be absorbed if electrons energy levels ei and ef are present, so that their difference equals to h nu. If their difference equals to h nu, then photons absorb and electrons jumps from valence band to the conduction band. In an ideal semiconductor, electrons can populate energy level below the so-called valence band and above for conduction band. And next process, subsequent separation of photo generated charge carrier in the junction. Electrons whole pair will recombine, the electron will fall back to the initial energy level. We know that if we incident photons on the solar cell, the electrons jumps from the valence band to the conduction band, and after some times electrons come back to the initial state, and electrons release the energy in the form of photons. And there is semi-permeable membranes in solar cell, must be present on both sides, such that electrons only can flow out through the membranes and holes only can out through the membrane. In most solar cell, these membrane are formed by N types and P types material. And third process, collection of the photogenerated charge carriers at the terminal of the junction. Finally, we can collect the charge by connecting terminal at the end of the solar cell. And next topic is solar cell parameter. That is external solar parameter, short circuit current density, open circuit current density, fill factor. And we will understand fill factor by graph. The fill factor is the ratio of the maximum power, that is JMPP VMPP generated by solar cell, and the product of VOC with JSC. And conversion efficiency, the conversion efficiency ratio of the maximum generated power and the incident power. How much power is incident on the solar cell and how much outcome we will get. And this is the graph of the solar cell. The VI characteristic of solar cell lies in the fourth quadrant of the coordinates. In the graph x-axis, on the x-axis we plot voltage, that is open circuit voltage when circuit is open. On the y-axis we plot ISC, that is short circuit current. And if we the graph will lie in the fourth quadrant. If we draw a square of maximum area, the square will cut the square. If we draw a maximum uh, area of a square in the fourth quadrant, the square will cut the uh, x-axis and y-axis. We measure the correspond voltage and corresponding current on the x-axis, on y-axis, and the ratio of the uh, J, JSC and VOC. Then this is the fill factor, that is this maximum power, maximum current, and maximum voltage. When we draw the maximum area of a square in this quadrant, in this in this quadrant, then the corresponding voltage and current, this is Pmax. We know that the product of the voltage and current, this is power, and the product of VOC and JSC, this is VOC and JSC. This is when graph cut the y on y-axis and x-axis. This is ratio of the fill factor. And the application of solar cell, we use solar cell in the remote location, in the hill areas and the mountains, and power in space. That is very important use of the solar cell in the space and building related needs. We plot and we in buildings we mounted a solar cell on the buildings. By the help we can generate more power by the solar cell. Advantages of solar cell is it does not produce a noise, as it does not have any moving parts, and it does not require fuels and water to produce electricity. It does not generate emission or radiation, and solar cell have long lifetime, about 30 years. It needs less capital investment. And disadvantage of solar cell, it cannot be used in absence of light. We cannot use solar cell in the absence of light, but the we use solar cell uh, in night by charging battery. It gives a very high initial cost for installation. At beginning the solar cell gives high um, uh, cost, but in future it will give more and more electricity. During cloud weather, less power is being generated. Very large geographical areas needed to deploy solar cell.